We shall now be talking about public goods, a product that one individual can consume without reducing the availability to another individual and from which no one is excluded is known as a public good. In this module, we shall be studying about public goods, its characteristics, the supply and demand for public goods, and the Pareto optimal provision of public goods. After studying this module, you will be able to understand the attributes of public goods, know about the demand and supply of public goods, know about Pareto optimality in the context of public goods, know about the distinction between merit goods and environmental goods. So now let us try to understand why public goods are non-rival and non-excludable. The basic nature of public goods is non-rival and non-excludable, which makes them different from private goods. For example, if there is a loaf of bread with the shopkeeper and two consumers want to purchase it, then both of them can't purchase it. The consumption by one person will reduce the amount available for another person. That is why if person A has purchased it, then it will not be available for person B. It means that there is rivalry for consumption between both of them. In another example of a beautiful flower in a garden, if two people A and B want to enjoy the beauty of the flower and A has reached the garden before B, then he could be enjoying the beauty before B has done it. But then when B arrives, there is nothing which prevents B from also enjoying the beauty of this beautiful flower. The act of consumption of the sensory perception of a beautiful flower by one person does not reduce the availability of this good to another person, and that is why there is no rivalry in consumption between them as far as such a beautiful flower in a garden is concerned. In this sense, this perception, this enjoyment is a public good. There is no rivalry and there is no cost associated with the additional consumption, while a cost is associated with additional consumption when we are talking about rival goods. A good is a rival if the consumption of that good by a person prevents other possible consumers to consume it, and it is non-rival if the consumption by one person does not prevent the other possible consumer to consume it. Like rival and non-rival goods, there are also rival and non-rival bads. Pollution is a non-rival bad because inhaling of polluted air by one person will not reduce the pollution level for others. Garbage is a rival bad. The consumption of garbage or the exposure to garbage by one person will reduce the availability. Garbage is a rival bad because the consumption or the removal of garbage for one person will reduce the availability of garbage for the other person. People are ready to pay the price for the consumption of a good only if they are and can be prevented to consume a good without paying the price. But if they can't be prevented to consume a good, they will not be prepared to pay any price. We don't pay the price for oxygen which we inhale because nobody can stop us from using it. People pay for swimming in a swimming pool where entry is controlled by a boundary wall, but they do not pay for swimming in a sea where there is no way to prevent them from entering the sea. Here, the swimming pool with restricted entry is a excludable good, while the sea is a non-excludable good. A non-excludable good also comes with open access where the good is available to everyone to use without paying any price for it. If there are n number of people consuming a private good, then the total quantity of the good Q will be divided amongst the n consumers. Assuming that C represents the consumption of each individual, then obviously C1 plus C2 plus C3 and so on up to Cn, when summated, when added, becomes equal to Q. While in the case of a public good, the quantity of that good available for each individual is the same, and that is equal to the total quantity of the public good. If G is the total quantity of the public good, then each individual from 1 to n has the same quantity available. That is, in the form of an equation, it is G1 is equal to G2 is equal to G3 and so on up to Gn, all of which are equal to an equal quantity G. Now, to make a good excludable, the specific technology or method is required. Entry into a swimming pool may be restricted by a boundary wall and by gates. The signals from a mobile tower may be restricted by having some kind of a jammer for particular frequencies of the signal. In all such cases, people are ready to pay because they may be restricted to use with the help of the given technology. But in many cases, no such technology is available to prevent people from using it. In the case of air pollution, the government can impose a fine if somebody is found polluting the air, but technically cannot restrict the polluting gases to enter the environment. In many cases of exclusion, the cost of exclusion is higher than the benefits of exclusion. The cost of fencing grazing land may be much higher than its benefits. A good example of a good which can be made excludable after the technology is available, if the benefits of exclusion are more than cost, is any such natural area like a park. The cost and the technology of exclusion both are two important factors for exclusion. Now let us begin our discussion on the supply of public goods. The supply curve for most of the public goods is just like the supply curve of a private good. If a city requires 10 bridges, then each bridge will be built separately, just like a private house, which is a private good. But after the completion of the private houses, the bridge will be used by individuals as rival goods. But in the case of a bridge, it will be used by all the people of the city and in a non-rival manner. The market supply X of such a public good will be horizontal summation of the individual supply curves. Therefore, we could sum up all the small x's which represent the individual supplies summed over the total possible sources of supply, and this would become capital X in equation 3, which is the summation of all such individual supplies. There are two exceptions to the standard summation formula: the weakest link rule and the best short rule. In the case of disaster, every member becomes equally important and the supply of the public goods will be measured according to the weakest chain. The protection from flood due to a nearby dam will depend upon the strength of the weakest point of the boundary of the dam. The supply of such public goods depends on the minimum strength of the boundary wall of the dam. Therefore, the aggregate supply becomes the minimum of all the supplies by all the producers. Therefore, capital X, which is the aggregate supply, would actually be equal to the minimum of all possible Xi's, and in equation 4 we can see that this spells out the weakest link. In case of the best short goods, the best result will determine the aggregate supply of the public good. A large number of researchers are working for treatment of HIV. The supply of the treatment of HIV will not depend on the results of all the researchers added together, but it will depend on the best result of amongst all the researchers. Therefore, X, capital X, which is the supply of the cure for HIV or AIDS, would be equal to the maximum of the Xi's, all the possible Xi's, and this is given in equation 5, and this is known as the best short approach. Next, we shall move on to the discussion about the demand for public goods. The derivation of market demand curve for public goods is different from that of private goods because of its non-rival nature. The consumption of a public good by one consumer does not affect the availability for others. We do not require making the bridge or the park separately for each individual. Therefore, we do not have to take the horizontal summation to derive the market demand from the individual demand curves, but take the vertical summation. The vertical axis measures the marginal willingness to pay by the consumer, MWTP. As all the consumers can simultaneously consume a non-rival good, we do not require to add all the quantities but to add their MWTP, the marginal willingness to pay. If Anish is ready to pay rupees 5,000 and Babita is ready to pay rupees 6,000 for making one park in the town, and then the aggregate demand shows 11,000 rupees as the marginal willingness to pay and as one as quantity. Assume that the demand equation for public good of X of Anish and Babita are given by the inverse demand function. The inverse demand function is given in equation number 6. PA is equal to A minus BX. This is a linear form of the equation and this represents Anish's demand. On the other hand, equation 7 gives Babita's demand. PB is equal to C minus dx. So, these are two downward sloping demand curves. Adding equations 6 and 7, we get PA plus PB is equal to A plus C minus bracket B plus D into X, which is the aggregate demand. Moving on to discuss the Pareto optimal provision for public goods. The question to find the efficient quantity of public goods or the bad to be provided may be resolved by using Pareto optimality conditions or criterion. The same Pareto optimal criterion discussed earlier or in other modules is used for various private goods in standard microeconomic textbooks, and it may be developed for public goods or even for public bads. From the consumer's perspective, an allocation is Pareto optimal if the marginal rate of substitution is the same amongst all the n consumers, that is MRS1 is equal to MRS2 is equal to MRS3 and so on is equal to MRSN, which is equal to an overall general measure of the marginal rate of substitution. From the producer's perspective, the marginal rate of transformation should be the same amongst the Z producers. Therefore, MRT1 should be equal to MRT2 equal to MRT3 and so on up to MRTZ, which is equal to the general measure of MRT, which is just MRT. Simultaneously, for the economy as a whole, the Pareto optimality requires that MRS in general should be equal to MRT in general. Let us modify these conditions for the pure public good which is non-rivalrous in nature. Now, suppose the consumers and the producers have a choice between public goods and the numeraire good, the good with which we are measuring the value of all other goods. Suppose we have two consumers, Anish and Beena. Anish is ready to sacrifice 5 units of the numeraire good through which we are measuring everything else for a public good. Anish's MRS is 5 and Beena is ready to sacrifice 7 units of the numeraire good for the public good. Therefore, Beena's MRS is 7. Then the value of this public good is 12 times the numeraire good for all the consumers taken together. The efficiency requires producing the public good at a cost 12 times higher than the numeraire good. Therefore, the modified Pareto optimality condition for a pure public good G for consumer I is the following in equation 9. Sigma I MRS subscript I for bracket G is equal to MRT bracket G. Now, for efficiency, this condition must be fulfilled. The left hand side of the equation 9 represents the value of public goods to the consumers, and the right hand side represents the cost of the public good for the producers. In case the left hand side is greater than the right hand side, the value of public goods is more than its cost of production. Therefore, we should produce more till the value of the cost does not become equal to the same. Similarly, if the right hand side is greater than the left hand side, we are producing a lesser value at a higher cost, so we must reduce the production for the sake of efficiency. In both of these cases, Pareto improvement is possible in the absence of equality, but no improvement is possible with equality. Hence, the condition of equation 9 provides the Pareto optimal condition for public goods. The same modified condition may be used for public bads. Pollution is a public bad. The marginal rate of substitution between pollution and the numeraire good for all consumers added together will represent the marginal damage to all of them. This MRS must be equal to MRT, which will measure the marginal cost of pollution abatement. We can also find out the efficient provision for public goods using demand and supply analysis. From this perspective, as you can see in the diagram, the efficient provision requires that we should produce the public good up to the point where demand curve intersects the supply curve. Before this point, the value represented by the demand curve is greater than the cost represented by the supply curve. Therefore, efficiency requires to produce more, and the vice versa after this point. As you can see, the blue line represents the demand curve for a non-rival public good, and the supply curve is the upward sloping red line. On the other hand, the demand curve for a rival private good lies well below the blue line, and it is represented by the green line. So, if we were to look at the intersection of the red supply curve with the green private demand function for rival goods, then the output, the quantity would be Q1. But because the demand for non-rival public goods is higher, therefore, at this point, it makes sense to increase the production of the quantity of the non-rival public good such that the quantity increases from Q1 to Q2, and at this point the red supply curve intersects the blue demand curve for non-rival public goods. Q2 is the efficient point for production of non-rival goods, while Q1 is an efficient point for production of rival goods. Therefore, the criterion remains the same, while the level of production changes depending upon whether the relationship, how the relationship is between the demand for a non-rival good vis-a-vis the supply curve in respect of a different demand curve which is for a rival private good for such private goods which are rivalrous in nature. So, in this diagram we have seen how efficient production of a public good can take place and how it compares with the production efficiency in the production of a private good. We will now understand what merit goods are and what environmental goods are. In the previous section, we discussed Pareto optimality provisions for public goods. The equality of equation 9 requires that marginal rate of substitution of the consumers, and similarly if we are using the equality of demand and supply curves again, it requires the demand by the consumers. In most of the public goods where the consumers have experienced them, so they can value them also. On the basis of these values, we can find the MRS and the demand curve. But in the case of merit goods, often consumers undervalue them. Merit goods generate positive externalities. With the positive externalities, marginal private benefit curve lies below the marginal social benefit curve, and the smaller quantity is produced and then than the efficient level. Education is a merit good, and generally we underestimate its benefits. Normally we underestimate its long-term benefits, which goes from generation to generation. Similarly, demerit goods generate negative externality and we overproduce them. Cigarette is a demerit good and we generally underestimate the harmful effects on the health of non-smokers. Environmental goods do not enter into the market and it is very difficult for consumers to find a value for it. Most of the public goods are available around us and the consumer is aware of their benefits. Because of this awareness, they know their value and can evaluate or put a price tag to its benefits. But environmental goods have a different case. Most of the people are not aware of the benefits and they find it very difficult to put a price to its benefit, and generally they underestimate them. In both the cases, merit goods and environmental goods, when we underestimate the benefits, we are not achieving efficiency in their production. Generally, we underestimate them as most of the people fail to understand the benefits that arise from the hidden positive externalities. Now let us summarize what we have discussed in this module. The basic nature of public goods, non-rivalrous nature and non-excludable nature makes them different from private goods. The derivation of the market demand curve for a public good is different from a private good because it is non-rivalrous by nature. The consumption of a public good by one consumer doesn't affect the availability for the other. Environmental goods do not enter the market and it is very difficult for the consumer to find its value. Most of the public goods are available around us and the consumer is aware of their benefits. Merit goods and environmental goods, when we underestimate their benefits, we are not achieving efficiency in the production of both merit goods and environmental goods, which are responsible for giving us positive externalities.